So, welcome everyone. My name is Esther Puyol, and today
we can't see your screen.
No, I will share now.
Okay.
Yeah. I thought first that everyone sees that, and I'm gonna be with Jorge Mariscal, who is sitting next to me, and also will be someone else, Tarin Daoud, who she will also be in the call, and all of us we will try to give you a brief overview on Python, and also we wanted to make it quite interactive. So ideally, I would like you to participate and also to do some sort of hands-on that you at the end get a feeling of what is programming in Python and how you do start and things like that. So now I'm gonna share the screen. Okay, so hopefully you can see now my screen. So
yes.
Mainly Python was developed in late 90s by a Dutch programmer, and the idea of Python is it's very user-friendly and also it's very interpretive and interactive. So compared to other language programs like we saw the last week C++, this is way more easier to program because you don't need to wait until the code is finalized in order to compile it and then see if there's any issue. So in that sense, it's quite nice, and I think it makes life slightly easier. Also, it's free, as we discussed last week, so that also makes it more available for researchers. And there's a lot of packets that nowadays are used for multiple things like statistics or AI that they are freely available. So I think this is the reason why I think we choose this language, because it's easier. You can easily do things, and hopefully, if you are planning to use it in the future, this gives you a good overview. So in order to use Python, there are two ways. The standard way, where you install it on your PC and you use it, but there's also nowadays Google Collab, which is a platform that is offered by Google, where you can run any code online and you don't need to really install it on your PC, which makes things a little bit easier and more useful. I don't know. Yeah, especially if you are a standard that you don't want to start installing a lot of things on your PC. And also the good thing with Google Collab is that it's linked to your drive. So anything that you do, you can then store it in your drive and you can open it later, that you don't lose any information. So in this session, we will be mainly using Collab just for you to give an idea of how it works, but also if you want to do any test or try how it works, that you can easily test it without having to install it. So let's now open Collab to see how it works and then give you a brief idea of it. So I'm just gonna open Collab. So when you open it, it's just called Collab Research Google. So what we can do is let's create a new notebook. So a notebook, it's just we need to replace. So unfortunately, sometimes it asks you to be connected to your drive in order to be able to save it. But okay, that is how it looks like, a notebook. So a notebook, it's just a compilation of code written in Python, but also it allows you to add some text. So the idea is that you can make it informative, so you can add comments or add anything that will help you to understand better what's going on behind the code. So first of all, what you see here, so to start with, the untitled 0 is the name of the file. So I would suggest that you change it, because otherwise you will end up with many files that have called untitled 0, 1, 2, 3 that they are not very meaningful. So just double click and just say, I don't know, Collab, for instance, or any name that you like. Okay, so that's going to be the new file. Then something else that you want to do. So if, for instance, you do file, save a copy in drive, it's when it's going to be asking you to connect to the drive, and then it's going to be stored in your drive that you can use it later. Also, you see this gray cell. This is a code cell. So here you can type any Python code and run it. So for instance, let's start with the most basic one, which is the print function. So if you do print, open parentheses, this is a function, so we are calling it. And then between quotation marks, you add anything that you want to display. So for instance, hello world. So this is your first Python program. And now if you press this play button, you will see that it outputs what we have introduced it here. So, and as I say, it's interactive, because now instead of say hello world, I want to say hello everyone. I just need to change it here and run it again, and it will change the output. So you can create as many code sets as you want and do different things in each of them, or keep going here. You can also do here print, oops, sorry, print example. And again, if we run it, we will see both of them. Something else that you also want to consider is that, for instance, the text cell. So in the text, you can add any information that you want. So this is a text cell, and you can also format it. So here you see on the right side that it appears the text that you have wrote. So let's say that the text, we want it to be in bold. Why not? So you can hear it change automatically, but we can also do things like add index list, or also as bullet points. And that could be more informative if you want, for instance, to make the program to do something and you want to then give it to someone else, that you can have some sort of documentation that they make them easier in order to use it. So now let's, one of the things to consider when you're using Python, that this is sequential. So if you first run this cell, the way that you run the cells is the way that Python compiles it. So that means if I now create two cells, and I want to say, for instance, I want to create a new variable which is called a, which I'm going to store with the value 5. And now I want to print it to see what it was the value of 5. So for that, first of all, a equal to 5, the only thing it's going to be is that the variable a is going to be assigning the value 5. And print a, as before, it's just going to printing whatever it's inside of the variable a. So if now, for instance, I run the print a command, it will give me an error. The reason behind is because we haven't run yet the previous line, so it's not aware of the variable a. So even if you put it here in as a cell, unless you run it, it will not be knowing what's going behind. So first you need to run the a equal to 5, and then if we run the next one, you will have here the value 5. Also, Collab tries to help you with, here you see there's some numbers, 3 and 5. So this is how it's been run, the sequential that it's been run. So 5, it was the last one. If we run it now again, was the 6th one. So now it will be 7. So if we run this one, now it's 3. If I run it, it should be the last one, number 8. So this also tries to help everyone to know which has been the order that is being run. Some things that you can also do is like, for instance, if you want the text to be on the top, because normally you give the information and then you make the code, there's here some arrows that helps you to move them up and down. Also, the same way, you can also delete the cell. For instance, you don't like this one, and you can create a new one. And again, you can put it on top or below. It depends what you want to do. So I think this is a little bit of the idea how Collab works. I think that's the main thing. Do you have any questions? As I say, also, you can then save it to the drive and it will be connecting directly. So is there anything not clear about this one? So far, it's quite... Okay, so now let's start. I'm gonna start with some Python introduction. So for that, I have put everything on my GitHub page. So I'm just not going to copy it here that you can have access, maybe not now, but after the tutorial. And in here, you will see everything that I'm showing today, but also there's way more information. There are some extra exercises that might be interesting for you to do in the future, because they're going from more simple to more advanced Python. So then if we want to use Collab, what we can do is you do file open notebook. And here you see that there's a tab which is called GitHub. And what we can do is if you type here, there are multiple notebooks. In this case, we're going to use the 2.1 introduction to types for this tutorial, but then you can go later towards all of them. So if now you do double click, it will open this notebook. And one thing I wanted to say, this workshop has been designed mainly for beginners, so people that don't have prior experience using Python or any other language. So if anytime you feel that it is too simple and you want to speed things, you can also go directly and do some of the exercises. And if you have questions, then you can ask Tarin, that she's also in the call, and she will be able to help you. So otherwise, we will go through step by step here for you to try to understand. And please ask any questions. You can cut me at any point, or Jorge, because I think it's easier if you ask on the spot than not wait until the end of the session, that then might be not relevant anymore, the question. Okay, so let's start. So the idea is, yeah, so taking it from here, we saw the previous one. Wait. It's not the one that I wanted to show, I'm sorry. It was introduction to Python, no, to this one, yes. So the first command, the only thing it's going to be doing is to link in this notebook with the GitHub page that I just showed you. This is just to be able to download the data we have there, or if we want to use anything. You don't need to worry about that now. So the idea is that we have started with the first program, with the print function, which is the most basic of Python. And as I mentioned before, you can do print and print anything that you like. And if we run it, it will just display the output, and you can change it to say any information that you like. So this is the first program that I think everyone will more hopefully understand and follow. And then based on that, we are going to build into more complex things in Python. And the first thing that I want to talk is about the types. So Python tries to help you a lot and just try to decide which is the type of the variable that you're going to be using. But just for you to understand, there are three main types of data. First of all are strings of charts, which just contains letters, like we saw before, the hello world. The second one are numerics, which it can be either integers or floating points, and this is just to store any numerical information that you want, like numbers. And the third one is booleans. And booleans is just could have value true or false, and in general they are used for comparison, like is this bigger than this one, yes or no. So if you want to make a comparison, in general we use booleans. But the good thing is Python will handle this for you. It's just good to be aware, because sometimes you can have some issues if you try to mix types. For instance, here I'm just creating a variable which is called a string, and I'm assigning the variable a value. And then what we can do is we can print the type of the string. So if we run this cell again, it's going to say, okay, a string, it's a type str, which stands for a string. We can also, as before, use the print command and do print a string. And it's going to show us first the value of the class and then the value. One of the things that with Python it's not possible is to concatenate a string plus a number. So if you remember the variable string, as we saw here, it's a string, and one it's a number. So if we try to run this, it's going to give us an error. And the reason behind what it's trying to tell you is that it's not possible to concatenate an integer int with a string. So what we could do if we want to fix it, we can convert this one into a string. And for that, we just need to add quotation marks into the one. So if you add quotation marks, you convert between a number to a string. And in this case, you can combine them. So as before, what we can also do is try to see which is the length of the string. So that means how many letters we have in it. And in this case, we use the keyword len. So len stands for length, and you can just do length of a variable, and in this case it's going to return you how big it is. So it's 12 because it has 12 elements that I am a value. Well, you can also convert between capital letters and smaller letters, and this is with the command upper and lower. You can also replace it, and for instance, we can replace the keyword, the word value with a string, and instead of being I am a value, it's going to now be I am a string. Or you can also add it, instead of being, before was size 12, if you now want to add it to be size 18, you can add it, for instance, with dots. Or if we change it here for stars, the only thing is going to replace in the dots by a star. So this is just for you if you want to create a string in a different way, so just you are aware of the different functionalities that you can use with the strings. And then, as I mentioned before, there are 4 types: the integers, the floats, the booleans, and the strings. And there's an extra type, the none, but I think we won't cover it, at least for now, because I don't think it's very relevant, or at least as a starting point. And here, the only thing that we are trying to do is we're trying to define multiple variables, and each of them are going to have a type. And then we are trying to use the print function in order to display both the value as well as the type, that we can assess if what we think it is actually it is the case. For instance, John equal to 1, it's an integer, so we will expect to be the output to be also an int. And that's the case. Then for Graham, it's going to be a boolean. It could be either true or false. We can also change here for false if we want, for instance. And the only thing that's going to happen here is now the value changed, but the class remains the same. So now that we know what are the main types in Python, the next step is how we build containers. So containers, where we want to use them is just to store multiple information. So far, all the variables only have one number or a set of strings. But for instance, we might want to create a list to combine multiple information. I don't know, let's say from the class, we want to store all the names of the students. So we don't want to have one of them. We will have a list that will contain all this information. And for that, there are 4 types of containers. The first one is the list that I was mentioning. And the idea of the list is just that you concatenate all the information in an ordered way. So for instance, if we create list, the lists normally are generated with square brackets. So in this case, we do the variable name, which is my list. And then 1, 2, it's going to be what is information inside of the list. So in this case, we will have a list which is called my list with values 1 and 2. We can also access this information. And in Python, for accessing, you start by 0 instead by 1. So the position number 0 will be the 1, and the position number 1, it will be the 2. It's a little bit confusing. So you just need to remember we always start by 0. Then also the hash, it's just to comment things. So for instance, here is to add a comment, but I can also comment these lines. And if I comment them, we won't see the output of them. So I think let's start this way. So we saw that my list was 1, 2, and if we do my list in 0, it's going to return 1. And if we do my list in 1, it's going to return as the value number 2. What we can also do, we can add more information to the list. Imagine there's a new student that has joined and we want to add the name. So in this case, we were going to use the keyword which is called append, and then we will add here anything that we want, for instance, the number 3. And in this case, if we now print the output of this list, it's going to be 1, 2, and 3 because we have added an extra element into the list. Similarly, we can also combine multiple lists. So in this case, we our list, which was the 1, 2, 3, and now we have generated a new list that we only have one element, the 4, and we know that it's a list because it has the square brackets. And then if we sum them, the output is going to be the concatenation that 1, 2, 3, and 4. Similarly, as before, we can also access the different values, and we can also replace them. So right now, in the position number 0, we said we have value number 1. What we are going to do now is change it to be value number 0. So the output of this, it should be 0, 2, 3, and 4. And we can do that for any of the elements. It can be for the 0 position. It can also be for the second position. Let's now change it to 11, for instance, and see what will be the output. So now you see that this 3 has converted into an 11. There's also another type of container that we can use, which is tuple. So tuple is very similar to list. It's just also to store some information, but one of the issues of the tuple is that you cannot change the information inside. So if you have defined it as 1, 2, it will remain static. And why you want to do that? It's because sometimes you maybe want to store metadata that you know that during the duration of your code, it doesn't change. It's going to be always the same one. And you also want to, if you share the code, that anyone can change it, for instance. So in this case, how you define the tuples, it's very similar to before. Instead of square brackets, in this case, they're going to be parentheses. So you use a variable name, the name that you like it, and then you do parentheses and the tuples as many as you want, as many elements as you want to store. Similarly, we can print my tuple that's going to be outputting 1 and 2. We can also access the tuple in the same way as before. If we do in 0, it's going to be the position number 1. If we do in 1, it's going to be position number 2. However, what we cannot do is we cannot append as before because tuples are not changeable. So if they start with 1, 2, it's not possible to change it. The only way to add it to make it bigger, it's if you concatenate a tuple with another tuple. So like here, do my tuple plus 3, and we have created another tuple. In this case, the output will be 1, 2, and 3. Similarly, it's not possible to change, let's say in the position 0, now we want to have value 0, as we're seeing here. This is going to give us an error because, as I say, it's not possible to change the tuple. So they are always remaining static. Whatever information you input is what is going to stay there. So the next thing that I want to discuss, because now we have seen how to access some of these lists or the tuples, and I think this is something very interesting. So as we saw before, you can put might tuple in 0, for instance, and you're going to see the value. But you might not only want to access one of the elements, you might want to access multiple of them. So for instance, if we now generate a new list which has values from 0 to 11, what we can say is, okay, I want to have all the values between the position 2 and 5. So for that, what we use is the colon command. So what you do is 2 is the initial value. So you want to go the list from the position number 2 up to which is the 5, it's going to be the end value. And 5, it's not included. That's the reason if we print it, it shows 2, 3, and 4. So if we want to include the number 5, we will need to change into 6. If we run it just for you to see it. Another thing is we can also want to go, okay, we want everything from 0 up to the element 5. You can here put 0, or you can also leave it blank, and in Python it will assume that you start from the beginning. Similarly, you can also go from 5 to the end, and this is quite nice because you might not know that there are 11 elements or 12. So if you put 5 colon nothing else, it's going to read, it's going to display everything that you have from the position number 5. Similarly, you can also do, I only want to show every other number, so you can use the colon command and then 2 at the end. So you see it's 2 colons and 2 columns and then a 2, and in this case it's only going to print every second number. And similarly, we can also do the starting from the element 1 to the 10th with a step of 3. So it's going to be the 1, the 4, and the 7 in our case. So hopefully this is clear, and also so this is a way that you can index, but also Python allows you to do it reversely. So you can also do minus something. So for instance, if you do num -1, it's going to give you the last element. If you do a column up to -5, it's going to show you from 0 to 5. And you can also go reversely, so from the last element to the first one, and that will be with column -1. On as before, we can also do in steps of 2 from the -2 to the -8 position, and in this case, it's going to show us the 10, the 8, and the 6. So hopefully this is not very confusing. I think it just needs a little bit of practicing and just try to do different tricks with the column command to see how you can index the different elements on a list. But this, I think, covers most of it. Then there are 2 more containers that I think they are quite interesting. First of all, is one is called a set. So a set, it's similar to a list. It's just the difference is that you just add elements in a non-ordered way, and they are unique. So for instance, if you create a set which contains element 1 and 2, so this is going to be 1 and 2. So it's very similar to the list. The only thing is now if we add the element 3, it's going to be added, but if we add it again, it doesn't do anything because you only take the unique elements in the list. So if we try to do this, you will see that, let's print it here and also before that you see that there's no difference between it. So 1, 2, 3, then we have added again, that's still 1, 2, 3. And also it's possible to compare between a list and a set, and for that you use the keyword list. So if you do list of a set, it will automatically be converted into a list, and then would be possible to add more elements and having repeated them. And the last container that I want to talk is about dictionary. So dictionary is just a way to pair data. So you have some keys and some values, and you want to be known that they are worked together. So for instance, we have a very simple dictionary that the only thing it's going to do is going to be converting between the words 1 and then the value 1, 2, and 2. So in this way, how you define it is using the set, so the curly brackets, and you say, okay, this is the key, which is the word 1, and the value is going to be 1. So you say key colon 1, and the same way the second position is going to be 2, which is the key, and then the number 2 is going to be the value. You can also add new information, and with that you're going to use the square brackets. So you do my dictionary in 3, it's going to be equal to 3, and this is going to create a new element in the dictionary. So let's, for instance, do int big here, and we'll do it after. And you will see how first we only have 2 elements, that we have a third element. We can also try to see which are all the keys, which in this case are the words 1, 2, 3, and for that we just do mydict.keys. Or if we want to see the values, we'll do mydict.values. And we can all access to see which is the correspondence. If we do mydict in 1, it's going to return as the value 1. So hopefully this is clear. I mean, dictionaries are a little bit more complex, but It's mainly used if you want to sort per data and if you want to be able to access, like if it was a real dictionary, let's say. Okay, so next what I want to talk is about the expressions. As in Python, you can do any expression that you are used to do by hand or in any other language. So you can do sums, multiplication, division, you can do comparisons, and you can also use, so in this case, it will be smaller, use these brackets, or also logical. So in this case, if you want to do, it will be like the logic in logic. So you use the word and or not. And I think these are the three more important. So arithmetic operations, the typical ones, sum, division, and subtraction, then comparison, smaller, bigger, or smaller than, and then logical, which in this case in Python, you use the word and or not. And here we have, for instance, an example. So we can sum 1 plus 2, which of course the value is going to be 3. We can also do the power. So in case of the power, it's with double star, 3 to the power of 2. Then we can also do a comparison. Is 3 bigger or equal to 1? In this case, it's going to be true. We can also do it's 4 bigger than 5 and 5 bigger than 4. So 5 bigger than 4 will be true, but 4 bigger than 5 will be false. And then if we do false and true, the result is going to be false. So this is, in this case, the output of this command. And now I'm going to give to Jorge that he's going to be carry on doing the next sessions.
To mute himself and unmute.
Cool, thank you, Esther. Lower down the volume. It's the volume. Perfect. Let me share my screen now. Hopefully everyone can see it now. As you can see it. Perfect. Okay, so I'll take it from here. We're going to look first at something called if statements. And what this means is that we are talking to the program now, and we are telling it a condition, which could be A, B, or something else. And depending on what condition we give to the program, it will decide to do something. So if the condition A is true, we will do something. Otherwise, if the condition B is true, we do something different. And if none of these conditions are true, we will do something else. And let's see what that looks like in code, actually. So here we have the variable Terry, which we have assigned a value of -5. And we have this kind of structure, if, elif, else. You can see straight away that because we have a negative number, we should get the text to print Terry is negative. Now, if we change that and we put a positive number, it should say Terry is positive. All we are doing is giving this condition, and then in our loop, sequentially, which means we first go to if, then we go to elif, and we continue going down, it will print Terry is positive. And finally, the edge case 0, well, the program will be confused and it will just print question marks. Very important to realize is that white spaces in Python mean something. So for example, if in our previous example, where we have if Terry is smaller than 0, we had the print at the same level as the if, this wouldn't make any sense because this condition is not actually within the if, it's just at the global level, just like Terry and other things. So very important. If something fails, straight away check that first. The nice thing about Collab is it normally, if you just press enter, will put you where you need to go. Okay? So another kind of flow control instead of the if is the while loop. And this is basically that while some condition is true, a statement will happen. And we will check continuously if the condition is still true. While it's true, we will continue doing whatever it says in the statement, and otherwise we'll stop doing that. So let's see an example. We have the variable x, which is equal to 5. And we have a while statement here, while x greater than 0. So we see straight away, we're going to go into the while loop because x is actually bigger than 0. We will every time print it to see what value x has in that iteration of the loop. And then what we will do here is for every iteration, x will be equals to whatever value x was before, -1. Let's just print it and you will see how that works. So we start from 5, we print 5, and then with every iteration we do -1 and we print it again. And the moment that this condition is not true anymore, which happens when x is equal to 0, we do else, which in this case is to print liftoff. And finally, the third kind of loop, we've seen if else, and while. Now we're going to look at the for loop. What the for loop does is you tell it how many times it needs to do something, and it will do it those many times. And the way we tell it how many times to do it, we can have something called a range variable, which in this case goes from 0 to 10, and it takes every third value. So we can print it so that you guys see what that looks like. It's not printing, yeah. I'll just print it individually. So in our for loop, what we do is we go into whatever values is, and we take each of the values from it, and we print it. So you take 0, we go in steps of 3, so the next one is 3, the next one is 6, and when we get to 10, that's the last value, 9. So we could have it just like this, so that it will print all the values from 0 to 9, for example. There we go. Or we could have steps of 2. So all we are doing is we are looking at the variable and we are printing all the elements. Then something that you use all the time, and it makes your code much cleaner, much easier to debug, and I really recommend it even from the start. It's very good to get used to using functions. It's because you can compartmentalize your code. You can have very small, like 5 lines, 10 lines maximum, that do a simple operation, but that way you don't have to write it explicitly in your main code all the time. And the way that you write a function is you have the keyword def in front of it, then you have the name of your function, which it helps if it's quite explanatory on itself, so that you know what it does. I think it's pretty clear. This is the sum of x and y. And as we can see, we have the return keyword here, which will just return x plus y. And the way we use it is the following. We just write sum, one argument, which could be 3, and the second argument, which could be 4. Let's say sum of numbers. And then we can print that. And non-surprisingly, the answer will be 7. So that's obviously a very, very simple case of how a function can work. There can be much more complicated functions, but the idea is that the more you get used to using them, the more you will be able to reuse your code. So sum2 in this case is summing 3 numbers, right? A good thing is that we can also have what we call default argument values, which is when we, in the argument, in the definition of the function, we say z equals to 0. That means that we can actually call the function sum2 without providing z, only x and y, and the default value of z will be 0. So 4 plus 5 is 9, and z was equal to 0. So if we add 9 and 0, we still get 9. If we have another example now, by adding a third argument, we will change this default value of z, and it will become a 6 instead of a 0. So now the sum will be 15. And finally, we can also call the variables by name, like we do here. And we are saying that x is equal to 7, y is equal to 6, and z will be equal to the default value in the function. So 7 plus 6. Another example of a function, we can return several values. We don't have to return one single value like we were doing here. So in this case, we are returning x plus y and x minus y. And that's why we get 9, which is the sum of 4 and 5, and minus 1, which is subtracting 5 from 4. Bringing it all together, don't get scared about the size of this function compared to the previous one. We are going to create a function that tells you the Fibonacci sum or sequence of the first 20 numbers. Okay, so let's go into the function one by one. First of all, we are saying that our value a starts as 0 and our value b starts as 1. We also have a list which is 0 and 1. Now we enter a while loop, and if you remember, a while loop will continue infinitely, until this condition is not true anymore. So we look at the condition and see if it's true at the moment. The length, which is the length of whatever we have in here, smaller than n. If we are providing 20 as our input, that means that n is equal to 20. And then the len of result will be equal to 2, because we have a list with 2 elements, 0 and 1. So we know that this expression is going to evaluate to true, and we will go into it and do whatever we have here. We have the sum of a plus b, then we are changing things around. We are saying that a becomes b and b becomes s that we calculated earlier. Don't bother too much about why we do this. This is just the mathematical definition of the Fibonacci sequence. You can look at it later and make sure that you're happy with it. And then finally, for each iteration of this while loop, we will append. So we will add to this list a new value, and this value is s. Okay, so I will just show you what is happening at each step for a smaller sum. So we're going to do 3, and we are going to print the value of s, the new value of a, and finally the value of b and the updated value of our list. Okay, so if you follow, the first print is going to be this one. So we have the sum of 1, and it's just a plus b, and a plus b was 0 and 1, so that checks out. Then a is equal to b, and b was 1, so that checks out here. And finally, b is equal to the sum, which was again 0 plus 1, so that's your 1. Now we have appended the value s, which was 1, to a list with 0 and 1. That's why we have 0, 1, and 1. And finally, we just print the value of the Fibonacci, which is the result. If we now do this without printing all the intermediate steps, we can do it for a much bigger number and just get the result at the end. There we go. So that's what the Fibonacci sequence does. And when do we stop doing the while loop? Well, you must realize that this result list is growing and growing and growing, right? Like it was 2, size 2 at the beginning, then we added 1, and we will keep adding. And at some point, the length of result will be bigger than n. And that's when we stop getting into this loop and we just return the result. Okay, that was a bit of a more complicated exercise compared to the previous one. But the nice thing of assigning multiple variables is that we can make it much more compact. And I don't recommend doing this straight away because it may put you off. It's normally better to just print things like we did here and to have one step on each line. But it's good for you to know that you can end up making everything this neat. And once you code a bit, it actually makes more sense. So we are doing exactly the same thing here. If we compare to what we have up here, we have a equals to 0, b equals to 1, and result equals to 0 and 1. We do all of that in one single line. So a is equal to 0, b is equal to 1, and result is equal to the list. And exactly the same thing for all the steps we had here. We assign these 3 variables here in a single line and do the append in the same way as in the previous function. And finally, we return the result and print it. And I will run it so that you believe me. There we go. Exactly the same result as before. It's actually more efficient. So once you learn to use it, it's 100% recommended. But up until then, please make sure that you understand what's happening on every step. All right, moving on to modules. What are modules? Well, the nice thing about Python is that a lot of people have worked with it before. And this means that you don't have to develop all the code on your own, especially for very simple mathematical functions and also for quite complex things. Someone has already written a library or a module that allows you to import such module and use their functions, so things like what we saw here, for your own purposes. So what do I mean by that? Let's look at the first line. We can import the math module, which contains a lot of useful mathematical operations and numbers and constants. So we do that by importing math. By the way, in order to know what the name of this is, you just go on Google and you ask Python mathematical operators. And it's pretty common that within the first few searches, you will find modules that can help you with that. Google 99% of the time has the answer for everything when it comes to Python. And what we do is we import the math module and we print something called math.cos, which stands for cosine of math pi, which is just the number pi, times 1.1. So we are calculating the cosine of pi times 1.1, and we get this. A nicer way, especially if you're going to be using the cosine function many times in your program, or the value of pi a few times, is to import it directly from the math module. So instead of having to, let's use the same for the purpose of the example, instead of having to write math.cos every time, you can simply import it as cos and import it as pi. And it does exactly the same thing that the previous one was doing. It just looks much neater because it's quite compact and it helps with debugging. All right, now moving on to two modules in particular that are very useful and that you should start using early on. The first one of them is Numpy. And what it does is it provides you with arrays, with matrices that allow you to store data that it's more than one dimensional, because so far all we've seen is a list of numbers. But we sometimes want things like this and even higher dimensions, right? So let's look into how we get this module working first. As I said earlier, we import Numpy, and if you go online, you will find loads of information about it. And whenever you get an error, please copy and paste the error into Google and you will find the solution straight away. Let's define what we call Numpy or Numpy arrays. Here we have a 3x3 matrix or a 3x3 array. We call it mp.array and we write it like this. We can also explicitly type what type of data we want for our numbers. So we are here saying that it's a float. So it's a floating point numbers that we have inside. And let's see some of the nice properties that this matrix has. Let's look first at representation of A. So it just gives you a nice formatted explanation of what this array looks like. We can also look at its shape to see what kind of matrix we have. It's a 3x3, 3 rows, 3 columns. We can also look at the number of dimensions, which in this case is going to be 2, because we have rows and columns. If we had, for example, a 3D array, which could be, a 3D volume scan of the brain, then it would return 3. We can do the same thing with size, which in this case is just going to give you the number of elements within the array. And finally, we can get the type of the data within this array, which, because we explicitly said it's going to be float 32, you shouldn't be surprised that it's float 32. So these are some of the most useful properties. And in fact, in my own research, this is what I use all the time. So it's good to get familiar with it and start using it as soon as possible. These are some other functions that you can use as part of the Numpy or Numpy module. You can have the identity matrix of any given rank. So rank 4 would give you a 4x4 and so on. We can also have something called a full matrix, which allows you to fill a matrix of the given size with a value, in this case 42. We can make it into a 3x4 matrix with value 33, and then that's what we get. And finally, we can also create a random array. This is good for debugging or just when you are starting your code. and it will just give you random numbers between 0 and 1 with a matrix of the size that you've provided. Okay, so as we saw before, you can choose an initial value, an initial type, sorry, for your array, but that doesn't mean that it needs to stay like that the whole time. So we can also cast it. We can change the type, and we are here going to change from float 32 to int 32, and we will see what type it is. Can you believe it? Initially, it was float 32. We just said that we wanted as int 32, and it did change it. So that's good. So it's a bit more advanced. When you start using these things, you know you are already quite good at what you're doing, but it may be very necessary for efficiency purposes. And finally here, we can just cast it as something else. Okay, similarly to what Esther just explained about lists, we can access these arrays similarly. We can give the position of the values that we want. So keep in mind that the array we are working with at the minute is 1, 2, 3, 4, 5, 6, 7, 8, 9. So first of all, we are going to look at the first element, the one in position 0, 0, which will be 1. That makes sense. If we now wanted 9, for example, we could do row 2, column 2, and we get 9. We can also get a subslice, which just means that we crop a 2 by 2 somewhere in this 3 by 3 matrix. And in this case, that's what we do here. We go from 0 to 1, so we get rows 0 and 1. And we go from 0 to 2 when it comes to the columns, so we go from 1 to 2, so that's why we get 1, 2, 4, and 5. Remember that Python, annoyingly, especially if you've been working with Matlab before, it does not index starting from 1, it indexes starting from 0. So that's why when we write 2 here, what Python is actually using is 2 minus 1, which is 1. More things. Now we can just get the column. So the column gives you the whole row, and the column 1 means that we look only at the values in column number 1. And finally, we can assign negative row 2 to column 2. So we can select some row or column and then put it into a row or column. We can do whatever we want with slicing. Just play a bit around and you'll see that it's quite powerful. All right, moving on to Booleans. We can use them in order to access or modify values. And this is quite useful because sometimes you want to check if a condition is true for your elements, or you want to just compare two elements. So you just do it like that. And equally, you don't have to explicitly write the expression that you want to evaluate. You can straight away write what you want to check. So true, false, or true. That means that you select the true rows, so the first one and the third one, and you leave out the second one. And there you go. If we look at the original modified array, what we are selecting is only the first row and the third one. We can also do basic math, so adding up, subtracting, multiplying, by simply adding a number, which is very nice because you don't have to create a whole array that contains 3. You can just say, take my array and add 3 to each value. And that's what we have here. Then in order to multiply matrices, so not a matrix and a value, but actually two matrices, we just use the function mp dot or directly the at operator. Yeah, we good on time? Okay, so finally, this is the second module that is very useful because it allows you to visualize the data that you're working with and the results that you're producing. And it's good to familiarize yourself with this as well and to use it as much as you can at the beginning. It's called Matplotlib. It's actually a library derived from MATLAB. So for those of you who've worked with it before, you'll be quite familiarized with it. And it basically allows you to make pretty plots and quite intuitive. It uses quite intuitive keywords for it. So let's look at what we have here. There we go. X is going to be some function that we create, and it's going to be moving from 0 to pi times 4. And it's going to do it in increments of pi over 20. That's all this means. So if we do that, it simply stores X. Then we are going to plot, first of all, the sign of that value. There you go. We've got X, as I promised, from 0 to pi times 4, which is approximately slightly bigger than 12. And then the blue line is going to be our sign of X. We can do the same thing for the cos, and then we will have both functions, one on top of each other. And finally, we can start making it pretty and add some titles. Perhaps you want to add a legend of what we are actually plotting, which was given here by the label. And finally, plot show. Okay, so you can see how powerful and how quickly we can just see the results. Obviously, you can do this with your own data and you visualize whatever you need. Let's say that we have an image instead of just a graph like in the previous one. Well, we create that image. We're gonna use the function mpGrid, which allows you to create a grid 400 by 600. And we are just going to populate it using some combination of sign functions with pi. Then we're going to print it, and then we're going to show it as a heat map, which is what you see here. There we go. So this could be some of your pretty images that you want to see. I think it's a good moment to stop maybe and see if there are any questions. So we either did it terrifically well or terribly. Okay. So I guess we can move to the next part. All right, let's look into a slightly more complicated part. Just like C++, Python is object-oriented, which means that everything is objects, everything is classes. Oh yeah, okay.
What is the keyboard shortcut to run the code?
What is the keyboard shortcut? If you're on a Mac, it would be Command-Enter. And Control-Enter for Windows, which allows you. So the question was, what is the keyboard shortcut to run the code? So if we are here and we don't want to press the play, we just do Command-Enter for Mac or Control-Enter for Windows. Yeah, it's very useful to start using it that way. Otherwise, you're going to be clicking that play button millions of times. All right. Yeah, so I was saying that what we work with when we're working with Python is classes. And a class is basically a set of rules and definitions that allows you to work with some simple units that can have some properties, which we can see here within the class dimension as an example. And the properties in this case are width and height. So you can think of some figure, some shape that has a width and has a height. And we use what we call a class constructor. So don't get put off by this, as I was the first time I encountered it. All it means by constructor is that whenever you call dimension, it will assign some values to the variables called width and height. And you are the one providing these values. So all you're doing is setting those values here. That's what a constructor is. Then in a class, you normally want to have some methods, which are basically the same as the functions we saw before, but they are connected to a specific class. In this case, I tried to call it somewhat intuitively getArea, and it's a method that will get the area of your dimension class based on the width and the height that you provided. Okay, so something to note. This class definition on its own won't do anything. This is just, as I say, a definition. It's a set of rules that your program needs to know so that it can do something when you actually call it. What do we mean by calling? The term is to instantiate a class. So we instantiate the dimension class, And when we do that, we create a dimension object, which only means we are creating some variable, in our case here a, which is of type dimension and whose width and height will be 10 and 12. That's all. So let's try and go step by step, because this is a very important part of programming, and I think we need to make sure everyone understands. Oh, yeah, we run the dimension class first, and now we instantiate the dimension class. There we go. So we set dimension 10 and 12. It has width 10 and height 12. We print a, and what we get is this weird line here. But if you look closely, it says it's a dimension object. So by instantiating, we created an object of the type of the class dimension. And this is just the address in memory. You can absolutely ignore this. Just know that each one of these objects will be stored somewhere in the memory of your hard drive or Google Drive or elsewhere. Then next, we print area. And in order to get the area for this specific object of dimension, we need to access the method getArea. Where is it defined? Well, in the class itself. The class method just returns the value of width times height. So 10 times 12 should give 120. We can, as I said, do this as many times as we want, so we can instantiate or create as many dimension objects as we want. And the good thing about it is they are completely independent of each other. So whatever we do to our new object, B, will not affect the definition of A. So we instantiated a new one with width 7 and height 8. And as you can imagine, the area of 7 times 8 is 56. If we now compare both objects and we ask the question, are A and B the same object? Not surprisingly, it will say false, because A and B are different objects. They are not the same object, even though they draw their definitions from the same class. I hope I was not too slow or too quick explaining this, but I think it's worth a try. Please do play around a bit with this, create your own functions, maybe change the way that we initialize the class dimension and see what you can get out of it. Next, operators. Just like before, the good thing about classes is we can use our normal operators, so arithmetic operators like plus, minus, division, with our classes. So I will show you how this works. We are going to instantiate again the same class as before, the class dimension, so that we get, sorry, let's run it now. We get a dimension object. Now we are going to add 5 to our dimension object, and we're going to print the width of A and the width of B. So we said that our A object has width 10, and that's what we are printing, 10. Now our B object is the same as our A object, but it has 5 plus for the width and the height. So that's why we get 10 and 15. And the same thing goes for the height. Our A object's height is 10, and our B object's height is 15. Also, we added a new method, apart from getArea, which allows us to add some value. This is a very convoluted example of how to use it. As you can see, this is much more intuitive, and this is normally the way you would do it. But I just want to show you that you can do this in a hard-coded and professional way, and you will get exactly the same results. And all we are doing with the method add is we are taking A and we are adding it to the original value of width and height. And you should not be surprised that by making B A plus 5 or B A add 5, we get the same results. Okay, how do we make a class or an object callable? So in other words, how do we make it into a function that does something for us? Well, we just need to add the call method that you see here. It's important to have the 2 underscores. And all we do is we say that this function call is going to print whatever we throw into this callable object which in this case was 1, 2, 3. So we just print 1, 2, 3. Getting to another property of classes. So this is again the same for other object-oriented languages like C++. We can inherit properties from another class. And this is very nice because it means that if you created a class that is very basic and you're going to be using all throughout your code the whole time, you can keep that class and use it to inherit some of its properties. So by inheriting, we mean that we can get, for example, from the class dimension that we defined earlier, width and height. But we create now a new class that will have some other properties because it's not enough with width and height. Maybe we want X and Y, which could be the X and Y location of some point. So because there's quite a lot, I will go line by line here. Again, we call this the constructor, and we say that we use the keyword underscore underscore init underscore underscore, and we need to provide 4 values. X, Y, width, and height. Please ignore self for now. Self just means it refers to the object itself, but this takes a while to understand. So just know that you have to use it while you're writing your definitions, but you will never provide it. You only need to provide the arguments that come after self, which are these 4 here. By inheriting, it means that we also inherited the initialization, so the constructor from the previous class, and that's what we are doing here. We are, with the keyword super brackets, we are just initializing our dimension class in the same way that we did before. Plus, we now need to add X and Y, which are the new variables that we have for our rectangle class. Again, we have some method, which is just a function, as you can see here, that will do something. It's not very important what it does, but just bear in mind that it will not only use the width and the height, but it will also use the new values that we provided in the rectangle class, which are Y and X. Okay, a lot of talking. Let's just see what this looks like. We are creating a rectangle object. We are instantiating it or creating it using the following values of X, Y, width, and height. And we're going to see that if we print R, we will get another object. In this case, however, it's a rectangle object, which checks out because that's the name that we gave to this class. It does not take the name from the previous class. It gets it from the one that we just defined. And just like before, we can look at different properties. We can look at R of X, for example. What is the value of the width? And you should see that because we are providing 20, it should be 20. Okay, so we can also, just like before, call the method getArea, which, as you can see here, it's not defined, which means that it must come from somewhere else, and obviously it just comes from our definition of dimension, which is here, getArea, which multiplies the width by the height. Okay, I'm running a bit. So if we do that, we get the area, which is 20 by 20, and then we can call the function inside of the rectangle, which evaluates to true. And finally, we can override, so we don't have to have the types from the previous dimension, but we can actually just replace them. So that's what we are doing here. We are overriding the add function, which up until this point was the one from dimension, but we are redefining it because it doesn't work for us anymore, and we do it within our new class. Okay.
Cool. Does anyone have any questions now? Don't be shy. You can ask anything that it's not clear. We can go back to the... No? Okay, now, but we were thinking there are 2 options. Either we can let you do some exercises on your own because there are several of them on the GitHub page, as Jorge is showing, from 2.1 to actually 3.2. There will be some notebooks where you can work, and there are also the solutions. But also, if you want, we can also do solve them interactively. So maybe we can select the 2.2, and then Jorge and me will be solving. And also, if you want to participate, please add your answer on the chat, that we can make it a little bit interactive. So it's really up to you. Also, as I said before, if anyone thinks this is too basic, please feel free to go to the notebooks, do it on your own, and ask any questions to Tarin that she will be very keen and help you via chat, or even you can call her. So, any preference? No? Well, maybe we start with 2.2 and see how it goes, and maybe start solving them, and then if at some point you think everyone thinks it's best to do it on your own, we can then stop and you can carry on later. Yeah, I think 2.2.
Sounds good. Okay. So, because it's been a while since we opened the Collab notebook, let me just show you the steps again. We go to Collab, Google Collab. It will come up with this screen that we have here, and we need to click on the GitHub tab. And here we can straight away put the link to our repo. In this case, it's going to be 2.2, loops and functions. So I can open it here, copy and paste, and just paste it in here. There we go, loops and functions. So that allows us to load it and work on it. All right, if anyone struggled to get that, please let us know, because it's easier if you have it in your own computer. Okay, so I talked a bit about if, else, while, for loops. What we are going to do here is a few exercises where we actually put it into use, and we see how it can be used for your problems. So I'm going to skip these examples. These are examples that you can run so that you better understand it. It's already completed for you. And I'm going to go straight away into the exercises. So you can see you can do a lot of exercises on here. All right, exercise number 1. It asks us to print the first 10 natural numbers using the while loop. I can actually clear all outputs so that you don't see the answers beforehand. All right, so we will use a while loop. And we need to print the first 10 natural numbers. So while loops work like this. While something is smaller than something, do something, right? Well, in our case, we can say n equals to 10. Now, some people start natural numbers from 0. Some people start it from 1. It doesn't really matter for the example that we're going to run. I'm just going to do it the way that Python does it. So n is going to be equal to 10. So and we have y equals 0. Within the loop, we need to add a value so that it increases with every iteration. We can print it every time, and hopefully run anyway. Yeah. So I wrote here I plus equals 1. This is the same as I equals I plus 1. It's just a shortcut. It's a way for you to write it a bit more compact, and it does exactly the same as you will see. Okay? So again, at the start, maybe get used to writing it like this so that it's very explicit and very clear what you're doing. Once you become familiar with that, change into this expression. All right, the next one. Write a program to print the following number pattern using a loop. So I will give you the easy answer that doesn't print exactly this, but it's more intuitive, and then I can give you a way to exactly print it the way it's shown in here. So this looks pretty much like a list, right? 1, 2, 3, 4, 5, and we just need to print that. So what I'm going to do is I'm going to create a list. There are definitely many different ways of doing this exercise. So this is just one of them. You can come up with your own ones. So 1, 2, 3, 4, 5. The way a for loop. Oh, it says a program. No? Should I? Oh no, but it's fine. We don't need to go program. for I in my list. And what this means is we will access each one of the elements within the list in time. So the first one will be 1, the second one will be 2, and so on. Print my list underscore 2. We will have this list here, and initially it will be empty, and we will use an operation that we saw with Esther, which is to append, which means to add some kind of element to this list, and then we can just print it. So we are going to append I, and we are going to print my list every time. Okay, so here we go. What did we do again? We created an empty list, which means it doesn't have any elements. We iterated over the original my list that goes from 1 to 5. We took each one of the values, 1, we added it to my list 2, and then we printed it. And we repeated that every time. So this list just keeps growing by appending new elements at the end. So that's why we get 1, 1, 2, 1, 2, 3, and so on. There is another method of writing this. I just learned this today, but you can also differentiate like this and provide the separator that you want to use. So this means that we will not write it as a list. We will not have the brackets. We will not have any of the commas, and we can choose what kind of separation we want. So if I now comment the previous command, there we go. That looks exactly like what we wanted up here. You can change the separator. You can have 2 spaces. You can have an underscore. It's quite nice if you want to show results and you don't want to be manipulating your list too much, okay? But normally for visualization for yourself to see what values are in the list, this is more than enough and it's much easier. All right, exercise 3. Find the factorial of a given number. So by definition, the factorial of a number is just the number multiplied by all the numbers in between itself and 1. So as you can see here, factorial of 5 is 5 times 4 times 3 times 2 times 1 equals 120. And this exercise is asking us to use a loop to find the factorial of a given number. So again, we say number is equal to 5. I will use a for loop, but again, there are many different ways to do it. I will just use one of them. For I in range from 1 to 5, or number actually, plus 1. Now let me stop here for a moment. Again, Python is not like Matlab, so we start from 0. But in our case, our definition of the factorial does not have a 0. And in fact, if we multiply by 0, everything that comes out of it will be 0. So we need to say that we want our range to start from 1 instead of 0. And then we tell it that we want to go to number. However, if you remember, this number is not the last one that is printed. It's this number minus 1. So we need to add a plus 1 here. You will see it much clearer when I now print this number every time. 1, 2, 3, 4, and 5. So you will fail to do this many times, and that's how you will learn it, because it's very painful and it will give you quite a few bugs. But please keep in mind that this is very important and you have to always keep an eye out for this kind of mistakes. So now that we have our numbers for the loop, we will do factorial. We initialize it as a 1, because if we initialize it as 0, it will again be a problem, because we will be multiplying by 0, which is equal to 0. And we say factorial is equal to my previous value of factorial times whatever value I am looking at now. So this will go through the loop and it will do 1 times 2 times 3 times 4 times 5. And at the end, just so that you believe that this is true, I will have to print it. And we saw here that the expected output is 120. Ta-da! Surprise! 120. This is definitely a not very efficient way of doing it. In fact, for loops are very inefficient, but you need to learn how to use the code before you can start making it efficient. So for now, you know, use it as much as you can, because they are a powerful tool. And if your computations are not crazy, then it's definitely worth just using a for loop. Okay, next thing, reverse a given integer. So we are given 76542, and we want to reverse each one of the digits and put it on the opposite position. We use slicing or indexing, and we have to do a few tricks. So first of all, number is equal to 76542. How much do we have left? I'm almost done. Is that good, Esther? Yeah. We have a number. Let's look at the type of the number. Matlab, Python decides what kind of type we have, and it sees this number and decides it's an integer. It's pretty smart, so we probably got it right. But we are going to operate on a string because it's much easier to operate on them when it comes to slicing. So we're just going to say that number is equal to number converted, into a string. Okay. So now if we print the type of number, we get the type string. From the explanation earlier, when it comes to slicing, we can do the following: colon, colon, -1. What this means is we are going to go through all our numbers, but we are just going to reverse the order. Okay, so if we print number, the original one was 76542, and the new one should be 24567. I must add something else. This number right now, let's see what type it is. It's a string, right? And normally if you were initially operating with a type int, you probably keep that type. So be very aware of what kind of types you're operating with, because even though Python does it automatically, it doesn't mean that it's going to get the right one or the one that you want every time. So I would recommend that we do an extra step and we take this number and make it into an integer again. So this is nice, right? We're going from an integer into a string, performing some operations on the string, and then converting it back into an integer. And now we should see that the type is again int. Only 3 more exercises to go. Okay, we are gonna write a loop that prints out all numbers in the range 0 to 1000 that are divisible by 3 and 5. So we have some for loop, we have a range, and we have some conditions that are divisible by 3 and 5. So let's go step by step. The range is 0 to 1000. So I'm going to say that my number is 1000. I'm going to start my for loop again as for I in range from, was it from 0? Yeah, from 0 to number plus 1, so that we get to 1000. I am going to print something, but I'm not going to print it every time. There is some condition. And the way that we tell the program about conditions is using if. The condition is that the number should only be printed if it's divisible by 3 and if it's divisible by 5. And for that, we use what we call the modulo operator. This one here, the percentage sign. And all it does is it looks, I will do it here so that you can see, 3 modulo 5. It gives you the remainder of this operation. So 3 divided by 5, it cannot reach 1, so what we have is 3. 5 divided by 5, it's 0, because 5 divided by 5 is 1, and we don't have any remainder. And if we do 6, it should be 1. Okay, so that's what we are going to use up here. If I, which is the current number we are looking at, divided by 3, is equal to 0, from this example here, a number, the modulo operation will give 0 whenever the number is divisible. So 20 is also divisible by 5, so we get a 0, and so on. So that's our first condition, but we have two conditions, and we say if condition A and condition B. Condition B will be written the same way, but instead of 3, we want it to be divisible by 5. And finally, if this condition is true, please print my current number. So hopefully, if I didn't make any mistakes, we will get a long list, which, as you can see, is those numbers that are divisible by both 3 and 5, all the way until 1,000. All right, exercise 6. Write a function to multiply all numbers in a list. So I'm just going to create a random list. 3, 4, 1, 3, 4, 2, 4, 5, minus 4. Okay, so this is the list we are operating on. And we want a function to multiply all the numbers within this list. So def multiply, and we need to give some kind of input to this function, which is just going to be my list. And now here we write what we want the function to do. So we can have a for loop, for example, which looks at all the values in this list. For I in my list, do something. What is that something going to be? The result is equal to the previous value of the result times I. And we need to initialize result equals 1, so that the first time that we go in here, it knows what to do with this result. And obviously multiplying by 1 doesn't change anything, so that's okay. And then the final thing that a function needs to do is to return something, or to do something that the user can benefit from. So we return the result. So we need to call this function multiply using my list. We can tidy up a bit and just have the function at the top, the list here, and the function here. And we want to get that result here, and then finally print it. So summing up, we have a function definition here, multiply, which takes as input a list of numbers, which we have defined 3, 4, 1, 245, and minus 4. It goes into a for loop, and it looks at each one of those elements. It multiplies them by the previous number that was stored in the variable result, and then it finally returns result. And we'll have to trust Python that that's the result of multiplying all these numbers. And finally, we are going to make it in the most inefficient way. We are going to check if a given number is prime or not. And the definition of prime is that it's divisible by any other number apart from itself or 1. So we have the number 71. And we are going to check all numbers up to but not including 71, starting from 2. So we need to write number here. What are we going to check? We are going to check for each value of I whether this number is divisible by I. So if number modulo I equals to 0, then print not prime. And I can tell you that 71 is a prime number, so that's why we don't get anything printed. I can give you a very easy to see prime number, 8, which is divisible by 2 and 4, and we get not prime. I can give you one that you for sure know is a prime number, and we don't print anything. This is the simplest way. Now you can play around. You can make sure that once we get here, we return something, so we can make this whole thing into a function is prime, and as input we can give number, and then we do all of this within that function, and then we just do is prime number, return 0, so that we stop after we find out that it's not prime. So 12, we only print it once, okay? And that's it. There are many better ways of doing this, but it's a good idea of how you can combine a function definition and a couple of loops, a for and an if. Take it away, Esther.
Cool. If anyone has any question on what just Jorge showed. You're very quiet. Hopefully everything is because it's very well explained. Otherwise, feel free to also after ask questions if you feel shy. Okay, so now I think we have seen a little bit of loops, which are very nice. Also some functions as we showed the last time. So I think you are covering most of it. So I think now we want to spend the last half an hour just talking a little bit about plotting, because I think this is a very important and most likely many people will be using it hopefully during their research. So I'm just going to share again my screen and go through one of the notebooks, which is about plotting things. So hopefully you can see it. So first of all, again, as before, I need to connect to the GitHub, and the reason behind is because we will need to use some of the images that are stored on the GitHub. So then the thing that it's doing here, Google Collab, it's just downloading and storing locally. So actually, if we have a look here now, yeah. So it has downloaded, and you see this is the same as you have in the Collab. So it's just that you see that it's been connected. So first, what do we need to do, because we want to plot things, as we were saying before, this is going to be using the library called Matplotlib. So what we need to do is to import them. And if you don't do this, anything of the things behind it's going to be working. So the first step is to import them. We're also going to import the Numpy because it's one of the most common use. So I think every time that you start a Python code, you can already say import Numpy as NP, because almost 100% sure you're going to be using it. And then the last line, Matplotlib inline, the only thing is going to try to make it stay on the notebook. So this is only necessary, this line, when you run as a notebook. If you run you locally and you don't use notebooks, which is another type of way to using Python, then you don't need this line. But for now, we just run it. So now we have imported the library, and now we can start playing with it. So first of all, let's start with the most basic. So the idea is that we have some data. So we want to plot some data, which is, first of all, X is going to be a values that goes from -10 to 10. So we are going to plot 50 values of it. And then the variable Y is going to be twice this X. So now before plotting, if we do print X and print Y, just to see what we are here storing. So are the values that goes -10 to 10, 50 values, and then we just do the multiplication by 2. Okay, so we have this, and now we want to plot. So to plot, it was the command plt, then plot, and then we plot X and comma Y. One thing that normally when you start typing Collab, it also tries to help you. It gives you a little bit of information. So this is from the documentation that comes from Python, and it tries to help you. So also if you don't know how it's written, so it says that plot normally goes first the coordinate X and then the Y. Let's ignore for now the rest. So if we now do this, what we're going to be plotting is the line. So it's just a line, X equal to Y equal to 2X. But this is not very informative because we don't know what is the X and the Y labels. So one thing that we can add in order to make it slightly nicer, it's the label. So for instance, we want to see this is the X and this is the Y, and also we can add a title to make it more informative. So what we can do, so if we then now do plt.xlabel, also Collab tries to help you to fill some of the syntax. So if you now press tab, it will fill it for you. So you don't need to remember everything. In Python, there are a lot of functions. So in general, if you do plt plot, it will show you everything, and you just need to remember vaguely the name, not everything by heart. So this is the x-axis, for instance. And let's do the same for the y. Plt dot y. Y-axis. So now you will see that it's the same plot as before. The only thing is now we need to plot it again. apologize for this. So first we plot the data and then we show the axis. So it's just giving you some information. Similarly, we can also add the title. So for that, there's the keyword title, and then just say this title of the plot. So now we have the same plot as before, just a little bit better expressed in the sense that we now have a title. We also can give some information about the axis. So if you want to plot something, it will be easier for you to know what is this plot about. But in Python, you can also plot more than one thing at the same time, as we showed before, that we were showing the sine as well as the cosine. So for that, if we want to do that, we can still use the plot function. So now let's define a second variable, which is called y2. What we are going to do is x to the power of 2. So first of all, we are plotting the xy as before, and now we are also going to plot x and y2, and this is going to be overlap one to the other. Before we have the labels, the x and the y, so we give here any information that we want, and we can also give some legend. So this is to know that which curve correspond to what. So the first one was the y, so it will be the blue one, and the second one is the orange, so it will be the y2. And the title, for instance, we call it 2 functions. So then if we run it, is we see the same plot as before, it's just that now it also overlays the second function, which is the y2. Now let's do it with a third one. So let's call y3 is going to be equal mp.x. And then here is going to be x divided by 2. And now we want to plot everything again. So we're going to do plt plot, then x, y. One option is also you can plot everything in a single line. So before we were doing plot x, y, then plot x, y2, and then would be plot x, y3. But we can also do x, y2, x, y3. And now what this should show, it's like the same as before, it's just the 3 lines together. So this is to make it a little bit more compact. So as before, let's put x label. Title. The legend. Sorry. So actually, this is good that it shows an error because it's Python also tries to help you to identify what is the error. So it's telling me that it's here and it's invalid syntax, and mainly was because I was missing one of the parentheses. So whenever now I click this one, I add the square brackets, it will show both of them. So that was the issue, and now we see currently the 3 plots together. But you might also want to show differently because maybe it's not very handy to have 3 colors. Maybe you want to show these 3 colors using different styles. So one of the things that we can do, for instance, is that we are going to use the red circles for the first function, then green circles for the second, green triangles for the second one. So what we are going to do is going to do plt plot xy. So this one remains the same. Then the second one, what we wanted to do, in this case, we say we're going to do red circles. So R is going to stand for red, and circles are as an O. This is on the documentation of Python. You don't need to remember this by heart. And then for the last one, plot, it's going to be green triangles. I'm trying. Finally, we are going to add the legend. It's just repetitive from before. So the only difference between this plot and the next one, it's just going to be the way that we display the plot. So instead of being lines, it's going to be now with dots or with triangles. So you can see here, and you can also do a combination. So you can show every of them slightly different. So this is quite interesting. So here we also use the documentation. So here it shows you all the possibilities that you have, how you can change it. Here you have all the markers. So you have circles, you have points, triangles, stars, octagon. So this is just for you that you have it, and then you can show it your graph as you think is best according to your experiment or whatever you're trying to show. Okay, now what we can also do is we can also change the limits. So for instance, here we're showing minus 10 to 10 with a steps of 2.5, but you might not want to show this. You might only want to show the minus 10, 0, and 10, or any other steps. It depends on how you like to represent your data. So for that, what we can use what it's called the command xlims and ylims, that the only thing that it's doing is going to change this one to show between the range that you want. So just for the sake of time, I'm just going to copy this and paste it. And then what we are going to do is here, I'm just going to say, okay, the x limit going to be from the lower to the maximum, and in this case we say that the lower is going to be the minimum of x minus 5, so it's going to be x dot min minus 5 up to x dot minus 5. So now if we have a look at what we had before, it was minus 10 to 10, so x was the minimum, we have it here before, so it also goes from minus 10 to 10, so this won't change massively. We just run it for you that you see. Oh, I forgot the 5. Good point. So now we have it goes minus 15 to 15, and then if we do the same for the lim, it's going to be, in this case, we want it to go from the minimum of y So again, we are changing the limits. So the difference between this graph and this graph is only the limit. So you can see that the data is being squeezed because there's nothing actually minus 10 to minus 15 or between 10 and 15. But it will be helpful sometimes if you want to represent, for instance, multiple plots in the same way that all of them has the same axis. Okay, so similarly, we can also change how many peaks, which are these lines here, we want to show. So here it goes minus 15, minus 10, minus 5, 0, 5, 10, 15. We can also say, okay, we only want to show minus 10, 0, and 10, and the same with the limits of the y. So for that, I'm just going to copy this again. So in this case, let's say that we only want to show, because we go minus 15 to 15, the minus 15, 0, and the 15. So what we can do is plot and 15, and we'll do the same for the y. This will be minus 20, 0, and the maximum was 20. So that's it. And now if we change it, for instance, between 10 and 10, you'll see that it only shows these ones here. So this is just a way that how many you want to show or display on the plot. Something else that you can also do with Python is you can create subplots. So this is only one plot, but you might want to show this and then next to or on the bottom too to show another plot. And this is to put all the information together instead of creating 20 plots. So that is using the subplot function. For the ones that are familiarized with Matlab, it follows more or less the same structure. So what you do is you first of all create a figure. So a figure is just an empty space, and you can give the size that you like. In this case, I should say A3, but we can also ignore it, and it will create some size for default. And then what we do is we create a subplot. In this case, what it's how you define the subplots is the number of rows, number of columns, and then the element of the subplot. So we do 1, 2, you're going to have 1 row and 2 columns, and then there will be the plot number 1. And for the second one, it's going to be the same. We have 1 plot, which has 1 row, 2 columns, and this is the element number 2. So what we are trying to show here, it was just the XY plot that we were seeing before and the XY2 that we were seeing before, but both of them in a different plot. So we run this. The only thing that's going to happen is that here you see one of them and then you see the second one. And again, we can also have a title different for each of them. Now let's say that we want to do the same, but in this case, we want to create, also show the Y3. Let's first do the 3.1, that it's the same, but we just want to change the size. So if we don't put anything here, you'll see this is the default size. It's kind of squeezy, so that's why we wanted to make it a little bigger. So maybe let's go for 23. You will see it's going to become very large and not very deep. We can also change it here, make it 5, for instance. So you can change it in a way that it fits you better on when you want to show or how you want to plot the data. It's also possible to change the sizes. For instance, if Y2 you think it's too small of the title, you can also change it. You can make it bold, or you can even change it to cursive. So anything that you want, actually, it's possible with Python. So now the second exercise was to add a third subplot. So in this case, if we have this, let's make it again as it was before. So we have one of them. So the only thing we are going to now is we're going to have 1 row and 3 columns. So I need to change this. Instead of being 1, 2, 1, it's going to be 1, 3, 1, because we need 3 columns. Similarly for this one, we have 3 columns. And now we are going to do the same. We are going to add the third subplot. And 3, 3, because it's going to be the third plot. And then PLT plot. We are going to show X and then Y3. And in this case, let's see how we can do it. We can do it, I don't know, black with a dash. Title, it's going to be Y3. So we have our new plot, which is the 3 elements. We can also again change if we want to make it bigger. We can also try to make it square. So as you see, you need to play a little bit how you look. It looks better. In this case, it looks very, very long, so it might not be very handy, but it's just about how you want to display the data, and this is a parameter that you can change. There's also some other plots that you might be interested in, for instance, the bar charts, the histogram, and the box plots. And for that, we are going to use some data, which is just comes from a class of 40 subjects, and we're just studying the height and the gender from them, as well as the distance that how long they need to travel in order to come to the university. So this data, it's on the GitHub account, so that's why we need to pull it from there. So it's from the content, as you were seeing here. It's VHF Python workshop, which is the title, and then it's the data is called 40 subjects, so it's this one here. Also, if you don't know the path, what you can do is click these 3 dots, and then you say copy path, and you can paste it, and will automatically tell you which is the location. So what we do here, we're using a new function or new library that we didn't see before, which is pandas. So pandas is very interesting because it helps you to load any structured data, which is CSV files or Excels, and it also helps you to do some of the operations. But in this case, we are just going to try to read the data. So for that, we do PD, which stands for the pandas, and read pickle. So pickle is the way that we have to store the data, but you could also have read Excel, for instance, if you want to read an Excel file. And then with df.head, the only thing is going to show us the beginning of the data. So it's only show us 4 of them. And we see that in this case, we have 3 columns. One of them is the stored information of gender. The second one is the distance that they need to travel to come to the university. And the third one is the height of these students. So then what we can also do is we can store each of them independently. So what we did here, we create a new variable called distance, and we access this df, which is the variable that stores all the data, and then distance. And this is going to be the second column. And we can also do the same. And in this case, we want to store the information of height, but we want to differentiate between male and female. So what we do is we take from the information of the height and then only the ones that have the flag equal to F. So in this case, it's going to be this, this, and this. And then in the boys, it's going to be only this one. However, the file is longer. Here we are just displaying the first 4 elements. So we run it. So now what we can also do, we can inspect the values. So for instance, if we do distance for values, what it's going to show us is all the values of the distance. So these are everything that we have. We can also do the same with the we can also print for instance, the boy's height. If we want to spec them, we need to use the word values. It's to access the information. So in this case, we have this is the height for boys, and it will be the same. We can do it for the girls. So now if we want to plot like the histogram of the distance that they need to travel, first of all, there's a command in the library Matplotlib that is blt.his, that what it's going to do is the histogram of whatever data we give here. So in this case, we wanted to do it from the distance. So if we do it, we'll see this is the histogram. And one of the things we can also play with how many bins we want. So by default, it's having a number, but we can also say number of bins. It's equal, for instance, to 2. So it's only going to show 2 bins. What is this called?
Bins, no?
Yeah, the word calling bins.
Just without N, I think.
Yeah. That's why there's the documentation. So that's the kind of things that you don't really need to learn by heart. So this is 2. If we go for 20, so it will just show more of them. So again, you can parameterize how you like to display the data. This is really dependent on what you want to show or what you think is the best way to show your experiments. Finally, you can also do charts. So in this case, if we have a look at the documentation, because the charts are a little bit more tricky to show, because in this case, we also want to show the standard error in the bars. So what we are going to do is we are going to use in this case the height for girls and boys. So we want to show the bar of it and also the standard deviation of it. So first of all, we need to compute the mean. So for mean, there are in Python, in Numpy has a function which is called mpmean, which is gonna just compute the average for you. And then we are gonna do height, and we do the same for the boys. And we can also compute the standard deviation. In this case, it's going to be mp.std for the standard deviation. mp standard deviation. So this is just computing the standard deviation and the average for the height of the girls as well as the boys. And then we will need to plot the bar. So it's blt bar. So how it works, first of all, we need to give the data. So in our case, it's going to be the combination of girls as well as boys, height. So it's just plotting this way. if it's int. This one.
I think it's you're giving an array, but I think it's expecting two things.
Position, show height. Son la solución. Wait. No, still. Whence?
It's missing one required positional argument, height.
Yeah.
So you're give it requires another positional argument.
No.
X and height.
Okay.
What is X?
X is just where you want to locate them. Just for this. Okay, it's tricking me. Okay. Just for this. Okay, there we are. So here we have the gas and the boys, and it's just showing us the average of them. Okay, I think for interest of time, I'm just going to show you how you plot an image, which was already what we saw before. But first of all, we can do image is equal to plt plot imshow. And then what we want to show here is the one which is called fetalbrain.jpg. So it's this one. Let's just copy the path. So this is just going to read the image, first of all. And then what we can do is we can do plot.figure and then plot.imshow. So here we are just visualizing an image. So here, again, we can also add a title if you want. And as before, we can do all the tricks that we were seeing before. So hopefully this is a good overview of what you can do in terms of plotting data. And do you have any questions? No? Anything related to this workshop? As we mentioned before, everything is going to be on the GitHub for the next year, so you can have access anytime that you want. And I would suggest that you, if you're interested in Python, that you try to go from 1.1 to 3.2, which they are building slowly. So the first one is just very basic. What we saw before is going to be introduction, which covers the most basics, and then you can go into the loops and the function we saw before, and then do more complex things like reading and writing, or plotting, or even using the pandas function that we saw just now that they didn't really cover it. So hopefully that was a good workshop for you, and unless you have more questions, I want to thank everyone for coming to the workshop.